Hello everyone, we had made part 1 before and we are going to be continuing with part 2, formation of precipitate. Let's start. Certain chemical reactions are characterized by the formation of insoluble solid substances called the precipitates which settle down at the bottom of the reaction tube. So they are chemical reactions, they are characterized by the formation of uh, some solid substances. What are these solid substances called? These are called precipitates, which settle down at the bottom of the reaction tube. They settle down at the bottom of the tube. Okay. Now, when a solution of silver nitrate, this is an example, is dipped into the solution of sodium chloride, a white insoluble substance, silver chloride is formed. So, we are going to be giving an example over here like AgNO3 plus NaCl, which is an aqueous solution, becomes AgCl plus NaNO3. Okay, so silver nitrate solution plus sodium chloride solution becomes silver chloride and sodium nitrate. So if you want to finish and learn this, so you have to just learn the first part because it is easy by learning the first part. AgCl plus NaNO3. If I hide this, even that you can understand it. Okay, next. Now, the second one, ferrous sulfate solution is added to sodium hydroxide solution. A dirty green precipitate of ferrous hydroxide is formed. So, let me write this FeSO4 plus 2 plus 2NaOH plus 2NaOH becomes FeOH and OH is in bracket over here, so FeOH2. Okay, FeOH2 plus Na2SO3. Okay, sorry, yeah, it is Na2SO4, Na2SO4. So this is the second formula which you will see right here. Now what is the last formula? Last formula is BaCl2 plus H2SO4. What is BaCl2? BaCl2 is a barium chloride solution, okay, plus H2SO4, which is sulfuric acid, becomes BaSO4, which is barium sulfate, which is also a bright precipitate, and white precipitate plus 2HCl hydrochloric acid. So this is the third formula. The let's write this down now. Okay, change of BaCl2 plus H2SO4 becomes BaSO4 plus 2HCl. Okay, so this is the third and the last formula. Okay, now what is the fourth one? The fourth one, oh wait, change in color, formation of precipitate, it is the third one. Fourth one is the change in state. Okay, change in state. So in many chemical reactions, we have learned what is a chemical reaction. What is a chemical reaction? Any chemical change in matter which involves a transformation into one or more new substances with entirely different properties is called a chemical reaction. Okay, and we have also learned about chemical bonds and more. So change in state, it is a reaction between hydrogen sulfide and chlorine. Both are gases produce sulfur, which is a solid, and hydrogen chloride, which is a gas. So this is a change in state. Two gases combined to form a solid and a gas. Okay, so what is this? This is a change in state. Okay. Now, change in state in many H2S, what is it? Is hydrogen sulfide, H2S plus Cl2 becomes 2HCl, which is hydrogen chloride plus S. What is S? S is sulfur. Okay, sulfur. Okay. And sulfur, this one is a solid sulfur. Okay, this is solid in form. So this is the change in state number 1. The second and the last one which we will learn about the change in state is when ammonia is mixed with hydrogen chloride, it becomes ammonium chloride. Okay, and what is the formula of ammonia, which is NH3 plus HCl. What is HCl? Hydrochloric acid becomes NH4Cl. Okay, NH4Cl, which is solid. Okay, it is solid, and it is ammonium chloride. This is ammonia, hydrochloric acid becomes ammonium chloride. Okay, so the one last one is the change in energy. Okay, there is no formula in this change in energy. Okay, so during a chemical reaction, when change in energy takes place. Example, what is one example? One example is burning fuel. Burning fuel. Number 2 is burning a fuel. A large amount of energy is released in the form of heat and light. Okay, the second one, during decomposition of calcium carbonate, heat energy is absorbed. During decomposition of calcium carbonate, heat energy is observed. Heat energy is absorbed. Okay. So these are the two for change in energy. So we are officially done in the characteristics of the chemical reaction. Okay. Now let's continue with the conditions necessary for chemical reactions. Okay. Number 1, it is close contact. So for a chemical reaction to occur, there should be close contact. Okay. So a chemical reaction takes place when two or more substances are mixed together. That means when they are mixed together. Okay. Next. Now, a chemical reaction are mixed together when they directly come in contact with each other. Example, when sodium metal comes in contact with cold water, an explosive reaction occurs. So that is why you say when you have sodium with you, never wash it. Like if there's a container which you had put sodium in, you remove the sodium, your chemical reaction is done. You should not wash it with cold water. right away, or else an explosive reaction will occur. So you have to put some chemical and remove the sodium, all the quantity of sodium, and then wash the container to water, not directly after your chemical reaction is done with sodium. This is one precaution that you should keep in mind. Okay. Now, there's a formula for this too. 2Na, 2Na, which is sodium, big plus 2H2O. After a vigorous reaction becomes 2NaOH plus H2. Okay. H2 is hydrogen. Okay. So this is the first formula. Now the second formula. No, there's only one formula in this, sorry. So close contact when they are mixed together, 2Na plus, which is sodium, plus 2H2O water, after vigorous reaction becomes 2NaOH plus H2. Okay, now the second is the attraction in the physical state of the reactants. Okay, attraction in the physical state of the reactants, which is through solution. Okay, now in some cases a chemical reaction occurs when substances are mixed in solution form. This brings the reacting molecules in contact with each other at a faster rate. Okay, so the attraction in physical state, in some cases this chemical reaction occurs when substances are mixed in solution form. So this is indirectly solution form. Sometimes such a big is solution form. Chemical reaction occurs sometimes due to solution form. Okay. Now let's give you guys an example. When sodium chloride and silver nitrate react with each other in aqueous solution form to produce a precipitate, which is silver chloride. Okay, so let me write it NaCl, which is sodium chloride, which is our common salt, AgNO3. See, we have seen this solution before as well. AgNO3 becomes NaNO3. I think, yeah. AgCl plus NaNO3. Okay. Now let's go for the third, which is heat energy. Heat. Sometimes heat is also needed. So some chemical reactions take place only in the presence of heat. When lead nitrate is heated, it breaks down into lead monoxide, nitrogen dioxide, and oxygen. See, if you have seen this was in the change of color, the third formula of change of color. Right? 2PbNO3, yeah. This was the third formula. So 2PbNO3 on heat becomes 2PbO plus 4NO2 plus O2. Okay. Now the fourth one. Oh wait, there are two in this. Okay, there are two. Okay, the second one is when iron powder and sulfur powder are mixed, they do not react. But when they are heated, they react to form a new substance, iron sulfide. So Fe plus S on heat becomes FeS, which is iron sulfide. Now, the fourth one is light energy. Some chemical reactions can take place only in the presence of light. They are called photochemical reactions. So light energy, photochemical reactions. Okay. Example, photosynthesis, right? Photosynthesis is a chemical reaction. Photosynthesis is a chemical reaction in which food, which is glucose, is prepared by the green leaves of a plant, but light is necessary for the reaction to take place. So let me give you guys an example. 6CO2 plus 6H2O on sunlight, and also chlorophyll becomes C6H12O6 C6H12O6 plus 6O2. I have told you before that 6O2, the 6 is written to balance the equation. Now the fifth one, there are 7 of them. Okay, fifth one is electricity. Okay, some chemical reactions occur only when electricity is passed through the reactants. We haven't learned this in 7th. Also pressure we have not learned. We have learned catalysts, right? So some chemical reactions only occur when electricity is passed through the reactants. Such reactions are called electrochemical reactions. So let me electrochemical reactions. So we have learned about photochemical reactions, which is due to light energy, and we have learned about electrochemical reactions, which is due to heat energy. Okay, water decomposes into hydrogen and oxygen, which are gases when electric current is passed through it. So 2H2O after electric current becomes 2H2. We use this to balance the equation, and also it becomes O2, which is oxygen. Okay, the sixth one is pressure. Okay, pressure. Some chemical reactions take place when reactants are subjected to high pressure. You have heard of hydrochloric press, like that. It puts pressure. So the same thing over here. So N2, which is nitrogen, plus 3H2. This is going to be a little hard. So make it okay. Let's write 450 degree Celsius and 200 ATM is a measurement like that. Okay, pressure becomes 2NH3. So 2NH3, this is how it becomes. N2 plus 3H2 becomes 2NH3 on 450 degrees Celsius and 200 ATM. Okay, the last thing which is there is the catalyst. You have learned catalyst in earlier in 7th, which is used to speed or slow down the reaction. Now we are learning a little bit more. Don't worry, it's not hard. It's positive catalyst and negative catalyst. It might sound hard. Positive catalyst. Okay, what are positive catalyst? They catalyst when a catalyst increases the speed of reaction, that is called a positive catalyst. When a catalyst increases the speed of reaction, that is a positive. And the negative catalyst negative catalyst is when a catalyst decreases the speed of reaction. When increases the speed and decreases the speed. Okay. So I'm going to be giving you an example for each of them. To increasing the speed of reaction is 2KClO3. Now don't think it's the same, it's the different one on MnO2 and 300 degree Celsius MnO2 and 300 degree Celsius. Okay, now becomes 2KCl plus 3O2. 2KCl plus 3O2. See, it is the same over here. See, but instead of 2KClO3 on heating strongly, so heating strongly, instead of heating strongly, it's MnO2 and 300 degrees Celsius, which is the catalyst, becomes 2KCl plus 3O2. Okay, now the negative catalyst, it's the same thing. Okay, when a negative catalyst, it decreases the speed of the reaction. Okay, when phosphoric acid reacts as a negative catalyst to decrease the rate of decomposition of hydrogen peroxide, oxygen 2 acts as a negative catalyst in certain chemical reactions. Okay, so when catalyst decreases the speed of the reaction and increases the speed of the reaction, so now what are enzymes? Enzymes, they act as catalyst. Okay, so enzymes are complex organic compounds made up of protein units. So they're organic compounds that are made up of some units of protein, and they act as a catalyst for biochemical reactions in the body cells for living beings. They also act like catalysts. We have learned before: positive catalyst, negative catalyst. Positive catalyst increases the speed of reaction, negative catalyst decreases the speed of the reaction. Like that, enzymes are also complex organic compounds made up of protein units that acts as catalysts for biochemical reactions. So these reactions can't happen in our body, right? So these are for biochemical reactions. So these happen in our body. Okay. Now, for example, the process of digesting food. Process of digesting food is done by enzymes. Okay. One meal can take 50 years to get digested. So one meal can take 50 years to get digested if not for our enzymes. So if our enzymes was not there, our meal would just take about 50 years to get digested, and you could only eat like about 2 meals if you live up to 100 years. So one meal can take 50 years to get digested if not for our enzymes. So because of our enzymes, the presence of enzymes accelerates means if not for our enzymes, the enzymes speed up the reaction, and hence the food can get digested in 2 to 3 hours. So every time you eat food now, thank our enzymes, or else you will only eat one time food and every 50 years. Okay, now the last thing which we are going to be learning is the amylase, trypsin, and lipase, which is small intestine. It helps to break down starch, fats, and proteins into glucose, fatty acids, and cholesterol into amino acids, respectively. So maltase is an enzyme present in the living cells of yeast, helps in the conversion of maltose is a carbohydrate into glucose. So maltose plus water becomes maltase. No, enzyme is maltase and it becomes glucose. Okay. Now the next is the enzyme zymase, which is present in the yeast cells, helps in the fermentation of glucose into alcohol. So C6H12O6 on zymase becomes 2C2H5OH, which is ethyl alcohol plus 2CO2. Okay, so that's it for today's video. Thank you very much for watching. Make sure to subscribe, like, and share this video. Goodbye.